Colby, 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 math.com.
Chosen to do number 5 with you. Number 5 shows a frequency table. Frequency tables serve the same purpose as a line plot or a stem and leaf plot. They order the data from least to greatest in a compact way to take up less space on the page. Dog food packaged by a machine in 20-pound bags varies slightly in actual weight. Use the frequency table to answer the questions below. If a 2/10 pound weight difference from the target weight is acceptable, how many bags were defective? Well, the perfect weight is 20 pounds, so these bags are perfect, and anything within 2/10 of a pound is acceptable. So I could have the bag be underweight by 2/10 of a pound or overweight by up to 2/10 of a pound and still be acceptable. So I'm going to box in these acceptable weights. The weights that would be unacceptable would be these 7 underweight bags and these 2 overweight bags for a total of 9 defective bags. If it's a word problem and there's context, we should always try to remember to include our units. Are customers more likely to get more dog food than they paid for or less? Well, these 9 customers get exactly what they paid for, 20 pounds. And these, get a different color. These 6 and 1 is 7 and 7 is 14 and 4 is 18. So 18 customers get less than they paid for, but 21, 22, 23 customers get more. So customers are more likely to get more dog food than they paid for than less. The range of the weights, so we learned the statistic song mean, the average, mode, most often, range, subtract the smallest from the largest. The smallest weight bag is this 19 and 6/10 pound bag, and the largest weight bag would be the 20 and 4/10. If we set this up with the traditional algorithm, we would line up our decimals and our place values this way, but it's really not necessary to find this difference. Just think, what would I need to add to 19 and 6/10 to get 20 and 4/10. You need to add 4/10 to get to 20 and 4 more to get to 20.4. So 8/10 is the difference. If you did this the traditional way, lining up a decimal in your difference, and you need to borrow from the ones place, but I have 0 ones, so I borrow from the tens place, making this 10 ones. Then borrow 1 1, which is of course 10/10 added to the 4/10 we had is 14/10. 14/10 minus 6/10 is 8/10. So the range of weights is 8/10 pounds. And what is the mode weight? This is one of the nice things about any graphical display, like a line plot or a stem and leaf plot or a frequency table. It's very easy. It's actually a little easier on a line plot than either of the other two, because on a line plot you'll have this large column of X's at the mode. Stem and leaf plot, it would still sort of jump out at you for the leaves that are repeated, and less obvious but still very easy to see on a frequency table, because frequency literally means how often each of these data points are occurring. And so the one that occurs the most is the one with a frequency of 13. There are 13 20.1 pound 20 and 1/10 pound bags, so 20 and 1/10 pounds would be the mode weight. So most customers are getting, a little extra, which if no manufacturing process is perfect, and you'd rather serve your customers well by having most of them get a little bit more than they paid for rather than a little bit less. The median is a little more difficult. I hope we did one of these in class, but whether we did or didn't, I'm going to ask you to try during the pause to figure out the median weight. I'll give you a hint. If you start listing these weights according to their frequencies, like this, it's going to take you forever, and you're defeating the purpose of having a frequency table in the first place. They're already in order from least to greatest. Find some way to find the median without having to do all of this work. During the pause, and then come back and see how you did.
Paused.
Okay, the median is the middle number, we know from our song. I think the best thing to do first is just figure out how many bags are represented in this table. We know we have 18, plus 9 more is 27, plus 13 is 40, and 8 and 1 and 1 is 10, so there are 50 bags. I have an even number of bags. There isn't going to be 1 in the middle, there'll be 2 in the middle, but I know I'll have 25 bags in my first half of my data, the low half. The second half, the higher numbers, will also have 25 bags. And so the bags that land in the middle will be the 25th and the 26th bags. And so if we just start looking at our frequencies, I've circled this 18 right here. 18 and 9 is 27. So the 25th and the 26th bags will both occur within this 9 bags, and those are both 20. So these two pieces of data in the middle are 20 and 20. And if the 2 in the middle are the same, obviously their average is the same, and so 20 pounds is the median weight. Which is also good news for this dog food company, because that's exactly the weight they're advertising on the bags. I hope this helped you with the homework. I'll see you tomorrow.